So now that we have completed our most of the topics in classroom study, we group 8 is here to present our project on one sample Z-test. Let's go. Z-test is one of the most popular technique based on the assumption of normal distribution. It was discovered by Karl F. Koch, who was the German mathematician in the earlier 20th century. The normal distribution is one of the most fundamental statistical distribution used in the field of various research, with mu representing the central location and various measuring the dispersion. So there are three possible selection parameters. First is two-sided where mu is not equal to 0. The second is one-sided where mu is less than 0, mu 0, and the third is where mu is more than mu 0. So in this slide, we have shown the practical example related to the Z-test, in which we have shown that Dadm Z, which is a delivery service company, claims that they will deliver the product in 30 minutes or less on average, which means that there will be two situations. First one will be like the product will get delivered under 30 minutes or less on average, and the second will be like the product will take more than 30 minutes. If there's a situation in which if the product is getting delivered in less than 30 minutes, and yeah, there can be a point that yeah, if product will get 30 delivered under 30 minutes, so that will be called as null hypothesis. And the second one will be like if product it will get delivered in more than 30 minutes, that we call it as a alternate hypothesis. But the point is that will be depend on the current situation of the problem, that yeah, if the product is getting delivered under the 30 minute or more than 30 minutes, so there is a situation either we can reject it or accept it.
So in this slide, we see the scenarios where we use the z-test. So first of all, the places, the avenues where we use z-test are the education sectors. In case of education sectors, in schools and colleges, in the classrooms, we can see the test of Z-score being utilized. Secondly, in case of the business sectors, this is used in order to analyze the various types of business models. Thirdly, in case of engineering sector, we can see that various researchers, in order to conduct some kind of a study, they use the z-test. Now, while speaking about z-test, we must consider a few points. Now, these are listed as you can see in this slide. Well, the first point is that the two samples must be separate and they should be drawn randomly. Secondly, while testing the samples, they shouldn't be taken from a single population. Thirdly, it's important that the samples must be independent. Now, coming to the second slide, we can see here we have tried to list down the ideal situations where we use this z-test or the z technique, so to say. Now, the first thing that we need to remember is that the sample size, that is n, it should be greater than 30. Secondly, it should be independent, as mentioned in the previous slide as well. Thirdly, the data should showcase a normal distribution. However, since that the n is greater than 30, this z-test, this criteria, this doesn't always matter. Also, the data should be selected on a random basis within a population. Also, the sample size should be equal.
So, as you guys are already aware, what do you mean by Z-taste? Its history, its story, where to use it, and the ideal situation to use it. So, with every taste, there come assumptions. So, as we all know, Z-taste are of two types. That can be done in two types. That is the one sample Z-taste and also the two sample Z-taste. So, coming to the first part, that is the one sample assumption. So, basically, while we are assuming things for one sample Z-test, we need to keep in mind three things. That is the sampling part, measurement part, and also the distribution part. And also, one sample Z-tests are considered to be robust in nature. Why robust in nature? Because this means that the assumption can be violated without serious error being introduced into the test. So, for example, as we already knew, that the central limit theorem tells us that if our sample is large, then the sampling distribution of the mean will be approximately normally distributed irrespective of the population distribution, shape of the population distribution. And also knowing that the sampling distribution is normally distributed is that what makes the one sample z-test robust for violations of the assumption of normal distribution. So coming to the next part, that is the two sample assumption, and that is very simple in nature. We need to just keep in mind two things. Whenever we are running a two sample equal variance z-test, and the assumptions are, the very first is that the two populations should be normal. They are normal. And coming to the second part, that the variance of the two distributions are known and are also same in nature. So that's it from the assumption side. Moving on to the next
So here
slide.
we'll be learning about the terminologies for one sample z-test. One sample tests are appropriate when a sample is being compared to the population from a hypothesis. The population characteristics are known from the theory or are calculated from the population. We have few terms that are very important here. One of them is the null hypothesis, which is the H0. It is a statement assumed about the value of any population parameter that we assume to be true, or we can say it as an accomplished fact. Then it is the alternate hypothesis, which we say or denote it as HA. As its name suggests, it is a contradictory statement which is in oppose of H0, and it tries to disprove the null hypothesis and prove itself to be true. Then we have another important term which is known as the significance level. It is the probability of rejecting any null hypothesis when it is true. Means we find the credibility of the hypothesis. Here in this question we have taken the alpha value as 0.95. Further we come ahead, we have a very important topic term known as the test statistic. Test statistics is used to calculate the p-value of the results, which helps us in deciding whether to reject or accept the null hypothesis. So it is mostly used in the statistical hypothesis testing. It has a very general formula, which is z equals to x bar minus mu naught upon sigma by root n, where z is the distance from the mean, mu is the population mean, x bar is the sample mean, sigma is the population standard deviation, and n is the sample size. We use this very basic concept, which is plan R, that we learned in the class, because if p value is less than alpha value, we reject the null hypothesis, or if vice versa, then we accept the null hypothesis. Now all these terms we will be using in the Pearson MyLab StatCrunch, and we will be doing this in the practical format. So here we go. Chapter 9 of Pearson MyLab, and the population mean of this sample of this data is 42. The first thing that we'll be doing is we'll going to start. We'll select z stats, then one sample with data. We'll be shifting the days. Standard deviation we know is 2.56, and our population mean is 42. Right now we'll be doing left side one tail test, so we'll be selecting this one and compute. So this is our first inference of left side one tail test. Similarly, moving forward, we'll again go to stats, then z stats, one sample with data. Again we'll be transferring days. Standard deviation is 2.56. The population mean is 42, and this time it will be right side one tail test and compute. Our confidence interval is 0.95. So this is the inference of the second one. Our z stat is 2.844 and p value is 0.0022. And finally we'll be doing two tail test. We're shifting the days. Standard deviation is 2.56. Population mean is 42, and this will be like this only because it is two tail test. Confidence interval is 0.95 and compute. So this is the inference of a two tail test. We show standard as 0.358, z stat 2.844 and p value 0.0045. And further its inferences and what can we make out of this data will be explained by Keshav. On to you, Keshav.
Now that the two tail test and the one tail test for left and right are being done, we will now compare the alpha values with the p values of each tail test. Now for the left tail test, we have received a p value of 0.998, which is greater than the alpha value of 0.05. This means that we accept H0. This H0 acceptance means that the mu is indeed greater than 42. Now coming to the right tail test. In the right tail test, we have the p-value of 0.002, which is way less than the alpha value of 0.05. This means we can reject the null hypothesis and state that indeed mu is once again greater than 42. Now for the two-tailed test, we have received the p-value of 0.0041. This once again is less than the value of 0.05. This once again states that we have to reject the null hypothesis and state that mu is indeed not equals to 42. It is either higher or lower, at least in a two-tailed test. Now the limitations for z-test. In a real life application, most of the time we don't have the population standard deviation. Under these situations, the z-test may not be a probable solution to any kind of a problem that we are facing with samples. Now here the threshold value we have selected is 0.05 of alpha. With alpha we can select any kind of a value which can be used against the p-value to judge our analysis. Now for the assumption checking. To make sure that the sample data set that we have selected is a perfect representation of the population data set, we plot a normal distribution chart. This normal distribution chart is a bell-shaped curve which makes sure that the sample data set that we have selected is indeed a perfect representation of the population data set. Thank you very much.